Yeah, so I'm going to talk about this system that we've created working for the Department for Transport in the UK, really focused on how you assure the safety of cabs, of connected and automated vehicles. Uh, so I guess many of you haven't heard of the Catapult network in the UK. We're one of 9 catapults, and we're non-profit innovation centres that were set up by the government, but we kind of operate in a neutral position between government and industry and academia, trying to promote adoption of new technologies and innovative practices. Okay, so you might be quite familiar with all this, but I'll just have a recap of what makes automated vehicles complex and challenging to prove the safety of. So first of all, we have the environment itself, the road and the weather, which are incredibly complicated and diverse. Next, we have a complex set of rules of the road that have to be followed. And if this is something like a speed limit or a stop sign, that's relatively easy to interpret. But quite often there's subtleties of behavior, and my example in the top left here is turning what's right in the UK across traffic. And in this case, it depends on where the other vehicle has stopped and whether the junction is offset or not, if you should go in front or behind the other vehicle. Obviously, we have merge conditions like this where the rules break down to some extent anyway, and you just have to cope with complicated human behavior. We have hand signals that can mean different things depending on how angry the driver is looking, for example, and sometimes chaotic situations like this bendy bus in the middle. And then on top of all those, we have the perception challenges. So we have rainy or dark conditions or sun glare as examples here. And we and the Department for Transport are very keen that cabs should be as safe as possible. And the way to prove this is really not by testing on public roads. You can't do enough volume of testing to prove that a cab is even as safe as humans. It would take you 100 cabs driving 24/7 for 12 years to do that much testing. So what are the solutions? Firstly, the solution is to use simulation as much as possible. This is a video showing Carla, which is one of the open source simulators. And that means that you can run tests in parallel, you can run them faster than real time, and you have precise control over the test conditions and parameters. And you can just generally massively increase the volume of testing for coverage. The second solution is to test against scenarios. So a lot of testing is quite uninformative. You might be driving along a straight, empty road, and you're unlikely to uncover interesting or unexpected behavior there. So instead, you want to test against well-defined scenarios. And on music, what we mean by a scenario is a short sequence of behavior showing the interaction of an ego vehicle, which is driven by the AD system, and potentially 0 or more other traffic participants. So in this scenario, we have an ego vehicle coming up behind a different active vehicle that does an emergency stop unexpectedly. And we want to just test that the AD system responds correctly to that kind of event. So this use of scenarios and simulation has really been what's driven the music project. And we've decided that a key first step to allow scenarios to be used in regulation is to build a library and a language for storing them. Essentially we built a proof of concept system over 2 years, during which we performed quite a lot of engagement work to make sure that we had the requirements correct, speaking to the ADS developers, test beds, other experts, as well as the regulators. And from the Department for Transport's perspective, they're quite interested in what's happening at the United Nations Economic Committee for Europe, particularly within the WP29 group, which has subgroups looking at the safety of cabs. And we hope that music will be eventually be a useful tool that can be adopted by those groups. All right, so this is what we've actually done. What we've built is this bit here in the middle. We've built this database. It's got a web interface where you can search for scenarios. You could do some basic editing and management of scenarios, and you can also export them. So the scenarios we assume are generated externally. For example, this is an animation showing Vector Zero tool, Roadrunner, and also the tools that you use to execute the scenarios are outside of our scope. This is an open source scenario visualization tool called ES Mini. And the other thing we've done is created the facility to have private databases run by, for example, an AD developer, so that they can store their own private scenarios, but still synchronize regulatory scenarios from a master database. And this is really, the import and export is made possible by our use of open standards. And that means that as many stakeholders as possible can easily engage with us and the system we're building. So particularly the scenario description language we use is based on standards from ASAM, which is a standardization body based in Germany. And they have Open Drive, which represents the road layout itself, things like the number of lanes, the topology, the intersections, the traffic lights and signals, and Open Scenario. And Open Scenario represents the dynamic elements within the scenario, such as what the other actors do and what the weather conditions are. And this scenario description language, SDL, is, as I said, quite important for us. And the Catapult has been quite engaged with ASAM on the working groups developing these standards. We've also added some extra data that we needed to store against each scenario on top of Open Scenario. We've added metadata because the ODD, the operational design domain of the AD system that we're testing, is quite important. When we envisage having a big database that stores every regulatory scenario, there'll be many different types of automated vehicle with different ODDs. And when we're doing the testing, we need to make sure we extract only the scenarios that are relevant for that vehicle and that ODD. So we've used metadata tags to enable that search process against each scenario. And those cover things like weather conditions, road features, level of traffic, other things that might be part of the ODD, as well as other tags that we've added, such as situation demand, which might be useful for testing. Is this a challenging scenario? Is it a more ordinary scenario? And custom tags to support, for example, tagging a set of scenarios that correspond to a particular UNECE regulation. The other addition that I wanted to mention is parameter stochastics. So we think that having a fixed scenario where everything unfolds according to predefined trajectories and timings is unlikely to give the test coverage that we need. So we allow variables within each scenario that can have values chosen randomly according to a distribution at scenario execution or scenario export time. And this, not only does it increase coverage, it means that developers can't design a system to pass a small fixed set of scenarios. And there's processes ongoing at ASAM to standardize these, in particular with Open Label and Open ODD projects. Just quickly then to give you an idea of how it fits into the wider picture, we see potentially an independent organization or potentially the AD developer themselves will be executing these scenarios and analyzing the results according to a set of pass-fail criteria set by the regulatory body. The scenario, as I said, the scenarios to be tested have to be chosen according to the ODD, which is supplied by the ADS developer. And obviously the test tools, the simulation tools has to be interfaced into the ADS itself. And once you've had a certification results, assuming this is happening independently from the AD developer, you need to feed back any problems with the system to the AD developer so that they can correct any issues. And this is very much just a straw man proposal at this point. It's still very much an open question of exactly how this is going to work, and perhaps it'll work differently in the short term, and then in the longer term there may be a more independent degree of testing and verification as part of a regulatory assurance. Okay, so I have another video which is just trying to illustrate some of this randomization, how the parameters can have random values. So we've got one basic scenario that splits into three different logical scenarios, which is our middle abstraction level. And then each logical scenario is split into three different concrete scenarios with different speeds and starting positions. And this is done within the system. It can do Gaussian or uniform or selection from a discrete sets of options for each parameter. So music is now being released open source, which means that it's available. We have both the live beta site that's available for everyone to create a login, and we have the option for people to set up their own installation of music internally to their system, which means they can manage their own private scenarios. But also for us, it means that everyone can align on the music format and technical infrastructure, and that makes it a seamless transition when we then want to test the regulatory scenarios for that developer. They have their setups and interfaces are already there. And obviously it means we can get code contributions and bug fixes and enhancements back from the wider community. Just to cover some of the engagement activities, for example, we had a workshop in June last year at our offices in Milton Keynes with a variety of presentations and interactive sessions. And at the URL, which is our main music webpage, we've got links to those presentations and also to a summary of the interactive sessions. So we had some good feedback that we've tried to build into our projects as they evolve from the stakeholders. For example, to acquire these scenarios in the first place, you can't just rely on the technology developers. You also need to make sure you include scenarios derived from real-world data, from experts and risk-based analysis processes, and from crash and accident databases, and in particular, as CAVs start to be deployed, from collisions involving CAVs. Yeah, we've been working on pass-fail criteria, and as I said, the wider process for type approval and assurance is still an open question. For example, we believe that it would be quite valuable to be able to test the perception systems of automated vehicles separately from the decision-making systems. To cover some more recent work on the pass-fail specification, having a scenario by itself is not really enough, because you also need to know what counts as acceptable behavior of the system under test within that scenario. And really, you want to be able to do this in a automated and entirely objective and clear way. So there's a range of possibilities here. You could manually look at every scenario, but that just doesn't scale. Or you could create a general set of rules that covers every scenario, which is sometimes referred to as a digital highway code. And this is incredibly hard technically. So we've proposed a scenario-based approach within music, where we set the pass-fail criteria for each individual logical scenario, which is the medium level of scenario abstraction. And this is much easier than having to define a generic set of rules that works in every possible situation. So we have two types of rules. We have prescriptive rules, which must absolutely be followed. For example, the ADS must not cause a crash. And we have risk-based rules, which are more aligned with existing automotive safety standards like ISO 26262. And this is situations where perhaps you want to ensure quality over a range of scenarios at a statistical level. For example, if another road user makes a mistake, you can't always guarantee to avoid a collision. So the kind of criteria we have are crashes that the ADS causes versus caused by others, traffic rules that should always be obeyed in normal driving, and then rules that should be obeyed as far as possible if there's abnormal events happening in the road situation. We think it's important to allow safety margins and to try to discourage confusing or inconsiderate behavior. And we have a paper on these results that's available on archive there that kind of outlines the framework and our initial thinking for how you can cope with pass-fail criteria. Okay, as I said, music was a proof of concept project that's now finished, and we've now got a successor project called CertiCav, again working for the Department for Transport and the Centre for Connected and Autonomous Vehicles. We're also working with WMG at the University of Warwick and a team led by Siddhartha Kastgir. And on this project, our goals are to look a little bit wider and develop a whole framework for how you assess the safety of highly automated vehicles, and also to demonstrate some of this with a simulation example, because this is, again, it's a focused one-year project. So we've got quite a large scope, which we've tried to reduce as much as possible by excluding things like security, functional safety, and in-use safety and monitoring, acknowledging that these are all very important topics. So that's one other project. And then another project I'd just like to mention is we've started to look at how CAVs can help decarbonize transport. And the opinion from experts here is a bit split. Yes, CAVs will definitely help emissions because they can drive efficiently and they can be shared resources, so you don't need as many vehicles. On the other hand, they might well encourage longer journeys, especially if people can work during their commute, or journeys that would otherwise have been made by other modes. You might take travel away from active journeys towards vehicles, powered vehicles. So our take has been, if it could go either way, maybe it only needs a small intervention in order to make sure that the deployment of CAVs results in beneficial environmental outcomes. And then the question is, what are the most effective interventions that can be done? And we have a scoping study that's being launched next week. People would be welcome to attend this event, and please drop me an email if you'd like the link, where we're going to launch our report that explores the key factors leading to carbon impacts of CAVs, and also outlines some scenarios that can be used to evaluate interventions. And this is scenarios in the sense of macro conditions within the transport network. Okay, I will leave you with just a short video showing some of the user interface of our music system, and happy to take any questions.